So in this video, we're going to look at compound interest. Now, in the first video, we looked at simple interest. So compound interest is another way of calculating interest. And so what exactly does that mean? Well, compound interest is interest that is paid on the principal plus previously earned interest. So the difference between compound interest and simple interest is that with compound interest, over the period of time, we're going to get interest on the interest. So let's take a look at what I mean by that. So example 5. Let's revisit example 1, but this time interest is going to be calculated at the end of each year. So if you'll remember example 1, I've got it summarized right here. Suppose that $5,000 is invested for 3 years in a certificate of deposit that pays an annual interest rate of 4%. So again, the difference here is that we are going to receive interest at the end of each year instead of waiting until the end of the 3 years. So our first question is, what will be the value of the CD at the end of the first year? So if we calculate interest, and we can do this by using our formula, interest equals principal times rate times time. So our principal is $5,000. So we're going to take our $5,000 times our rate, which is 4%. So as a decimal, that is 0.04, times our time. But this time, instead of the time being 3 years, we're asked about it at the end of the first year. So at the end of the first year, it's only been invested for 1 year. So our time's going to be 1 because we're paying it at the end of that first year, not waiting till the end of the third year. So if I take 5,000 times 0.04 times 1, that is $200. So at the end of the first year, we're going to be paid $200 in interest. So the value of our CD at the end of that first year is going to be our $5,000 principal plus the $200 that we just earned in interest at the end of that first year. So that is $5,200. So at the end of the first year, our CD is worth $5,200. So question B, what will be the value of the CD at the end of the second year? Well, now, instead of having just $5,000 in our CD, now we have $5,200 in our CD. So for the second year, we're not going to just get interest on the $5,000. We're going to get interest on the $5,200. So we're going to get interest on that $200 of interest as well as the $5,000. So again, I'm going to use my simple interest formula. Interest equals principal times rate times time. But now my principal for the second year is $5,200, and I'm going to get 4% interest of that for the second year. The second year is 1 year. So I'm going to have this $5,200 value for the next year, 1 year. So if I bring my calculator back in, for the second year, $5,200 times 0.04 times that 1 year, that's going to be $208 in interest. So for the second year, I get $208 in interest, which is more interest than I got for the first year because I'm getting interest on the interest. I'm getting interest on the $200 of interest as well as the $5,000 principal. So my value at the end of the second year is going to be the $5,200 that I started off with at the start of the second year, plus the $208 in interest that we just earned after the second year. And so that is $5,408. So after the second year completes, now the CD is worth $5,408. Question C, what will be the value of the CD at the end of the third year? So now for the third year, I have a principal of $5,408. So again, I'm not going to just get interest on the original $5,000. I'm not going to just get interest on the $5,200, but I'm going to get interest on the $5,408 during my third year. So again, if I use the formula, interest equals principal times rate times time, that's going to be 5,408 now is my principal for the third year, times my interest rate is 4%, and for my third year, so that's going to be a 1-year period for the third year. So if I bring my calculator back in, 5,408 times 0.04 times 1, that is $216.32. So this is 216.32. And so my value at the end of the third year is going to equal the $5,408 that I had at the start of the third year, plus the $216.32 that we earned in interest for the third year, and that is $5,624.32. So at the end of the third year, our CD is now worth $5,624.32. Question D says, compare the total interest earned here to that earned in example 1. Well, if I pull back in example 1 from the previous video where we just calculated simple interest for the whole 3 years, and remember the deal there was interest was only calculated at the end of the 3-year period with simple interest, not each year. So that's the difference. And the value at the end of that 3-year period in example 1 was only $5,600. So from example 1, the value was $5,600 at the end of the 3-year period. Here it's $5,624.32. So by calculating the interest each year and receiving interest on interest, we got $24.32 more in interest altogether because we were getting interest on the interest. So that's the difference. Compounding interest is significant. In this case, it's a matter of $24.32, but if we had larger amounts, that could be a huge difference that we have there. Let's take a look at example 6 next. So example 6 is pretty much like example 5. We're going to rework example 5, but this time interest is going to be calculated every 6 months, or semi-annually. Semi-annually means twice per year, so we're going to be calculating interest 2 times per year. So again, suppose that $5,000 is invested for 3 years in a CD that pays an annual interest rate of 4%. So we have a series of questions here. What will be the value of the CD after 6 months, after 12 months, after 18 months, after 24 months, after 30 months, after 36 months, which is our 3-year period. And then we're going to compare the total interest earned with what we got in both examples 1 and example 5. So we're computing interest more often here. So we're going to use the same basic approach as in example 5. Interest equals principal times rate times time. So we're starting off with our $5,000. That's our principal. And our interest rate is 4%. But now this time our time, we're going to be calculating interest after 6 months, which is 1/2 of a year. So our time is going to be 1/2. So if I bring in my calculator, 5,000 times 0.04 times 1/2, that is equal to $100. So after 6 months, we're going to receive $100 in interest. So our value is going to be our original $5,000 plus the $100 that we now just received in interest, which is $5,100. So after 6 months, our CD is now worth $5,100. So what's going to be the value after 12 months? So we're going to calculate interest for the second 6-month period, for the second half of the first year. So now, since we've received this $100 in interest, our principal for the second 6 months is $5,100. So we're going to take 5,100 times 0.04 times 1/2 again, because we're computing the interest for the second 6-month period, the second 1/2 year. So that's going to equal, if I bring back in my calculator, $5,100 times 0.04 times 1/2 of a year, so that is $102. So for the second 6 months, we receive $102 in interest. So our value of our CD at this point is going to be the $5,100 that we started this 6 months with, plus the $102 we just received in interest. So that is $5,202. Question C, what about after 18 months? So another 6-month period. So our interest is going to be principal times rate times time. So now our principal is going to be $5,202, because now that's what the CD is worth, times 4%, times for the next 6 months would be another 1/2 of a year. So 5,202 times 0.04 times 1/2, and so that is $104.04. So for this 6-month time period, we're getting $104.04 in interest. So our value is now going to be the $5,202 that we started this time period with, plus the $104.04. And so that is going to be $5,306.04 that our account is now worth. After 24 months, so another 6-month period is going to be going by. So interest equals principal times rate times time. This time, our CD is now worth $5,306.04, so that's now our principal, times 0.04 times the next 1/2 of a year, the next 6 months. And so if we do this calculation, $5,306.04 times 0.04 times 1/2, and so that is $106.12 if we round to the nearest cent. So this time we got $106.12 in interest. And notice how the amount of interest that we're getting goes up each time, because we're getting interest on the interest. So our value now is the $5,306.04 that we started this time period with, plus the $106.12 that we just earned in interest. And so if we add that together, I'm going to do that on the calculator so I don't goof it up, $5,306.04 plus 106.12, that is $5,412.16. So now our CD is worth this $5,412.16. So that's after 2 years, our CD is now worth this. So what about after 30 months? So the next 6-month period. So again, principal times rate times time. So now our principal is $5,412.16. We're going to get 4% interest for the 6-month period, so times the 1/2 of year. So if I take the $5,412.16 times 0.04 times 1/2, that is equal to $108.24 if I round to the nearest penny. So we're going to get $108.24 in interest there, and that's approximately equals. So our value is going to be the $5,412.16 we started with for this time period, plus the $108.24 that we got in interest. So $5,412.16 plus $108.24, that is $5,520.40. So $5,520.40. And so finally, what's going to be the value of the CD after the 3-year time period? So for the next 6 months, so we're going to take the $5,520.40 times our 4% times the final 1/2 of a year, the final 6 months. So if I take $5,520.40 times 0.04 times 1/2, that is equal to $110.41 if I round to the nearest penny. So $110.41. So finally, the value is going to equal our $5,520.40 plus the $110.41 that we just got in interest here. So $5,520.40 plus $110.41, so that is $5,630.81. So at the end of the 3-year period, if we calculate interest every 6 months, so we're compounding interest semi-annually, then we end up with $5,630.81. Well, how does that compare to examples 1 and 5? Well, again, in example 1, we just computed it all at once. That was simple interest, and we ended up with a value of $5,600 at the end of the 3 years. So here we end up with $5,630.81. So by compounding every 6 months, we get $30.81 more than we would have gotten in example 1. In example 5, at the end of the 3 years, when we were compounding 1 time per year, so we just did it at the end of each year, we had $5,624.32. So it was, again, $5,624.32. So here, by compounding every 6 months, if I take $5,630.81 minus the $5,624.32, that is $6.49. So we got $6.49 more by compounding every 6 months instead of compounding each year. So we're getting more interest. The more times we compound, the more interest we get, the more we make. So again, we went from $5,600 to $5,624.32 to $5,630.81. Well, so what if we didn't compound every 6 months? What if we compounded every month? Well, the trouble with doing it this way is we have a whole lot of calculations to do. So we're going to come up with a shortcut for being able to do that. We're going to come up with a compound interest formula to be able to do that more quickly. And so we're going to do that on the next video.